Have you ever wondered what an AI actually sees when it looks at a photo? I mean, really sees? Well, today we're going to peek inside the mind of a neural network and find out. Okay, let's dive right in.
We know that an AI can tell us there's a cat or a dog in a picture. But what's it really looking for? We call these systems black boxes all the time, and for good reason. It's kind of mysterious. But today, we're going to pry that box right open. So here's our game plan. First, we'll talk about cracking open that black box. Then, we're going to walk through how a simple picture becomes data that an AI can even understand. After that, we'll build and train our very own AI, and then, this is the really cool part, we're going to take a look inside its mind to see what it actually learned. So, how do you even begin to build one of these artificial minds? Well, it's actually a pretty logical, step-by-step process. It really just boils down to these 4 steps. First, you've got to get your data ready. Second, you build the model. That's the brain, basically. Third, you train it. You send it to school. And finally, the whole reason we're here today, you visualize what it's learned to get some insights. So let's start right at the beginning with the data. Okay, so think about this. How do we take a colorful, complex picture of, say, a car and turn it into something a machine can process? Well, it's all about translation. To a computer, this beautiful image isn't a car or a dog or a sunset. It's just a grid of numbers. That's it. Every single pixel has a value for red, green, and blue. The AI doesn't see color, it just sees the numbers that represent that color. So the very first thing we have to do is a crucial step called normalization. We take all those pixel values, which, normally go from 0 to 255, and we squish them down into a standard range. Think of it like leveling the playing field for all the data. It just helps the network learn way more efficiently. And next, we have to do something that feels a little weird. Our image starts as a neat 32 by 32 grid of pixels, right? With 3 color channels for each. Well, to feed it into our simple network, we have to flatten it. It's kind of like taking a ball of yarn and just unspooling it into one single long thread. Our tidy picture grid becomes one long line of 3,072 numbers. All right, our data is prepped and ready to go. Now it's time to actually build the brain that's going to learn from it. Our network's architecture is actually pretty straightforward. The input layer is the front door. It takes in our long string of 3,072 pixel values. Then, a few other layers start making decisions, and we use a clever little trick to make sure parts of the network don't just, give up and shut down. We also have a special rule that's kind of like a good teacher, stopping the model from just cheating by memorizing the pictures. And finally, the output layer makes its best guess, and it spits out a list of probabilities for each of the 10 categories it knows. And now, we send our machine to school. This training part happens over many rounds, and each round is called an epoch. You can think of an epoch as one full pass through the entire library of images. So in that first epoch, it's basically just guessing. It makes a ton of mistakes, but by the time it gets to epoch 50, it's really starting to see some patterns. And then, around epoch 100, its performance starts to level off. It's learned most of what it can from the data we've given it. So, the model is built, it's been trained, it has studied thousands and thousands of images. So, what did it learn? What does it actually see? Let's take a look. After all of that training, our little model here is about 46% accurate on new images it's never seen before. Now, that's not amazing, but for our simple network, it's not bad. But the real story isn't the final score. It's how it's getting there that's so fascinating. And here it is. This is it. This is what our AI has learned. These ghostly, kind of abstract images. These are the weights from the final layer of the network. They are, quite literally, a visual representation of what the AI is looking for. In a way, these are its memories. Okay, so let's break down what these bizarre images are actually telling us. I know they might just look like random noise at first, but I promise there are patterns hidden inside. Each one of these 10 little images corresponds to one of the 10 categories the AI was taught, like car, bird, dog, and so on. The best way to think about them is as a kind of ghostly template for that class. So when a new image comes in, the network basically holds it up against these 10 templates to see which one is the best match. Let's look a little closer here. Let's say, for example, that class 4 is the template for cars. The AI has figured out that a reddish blob right in the center of the image is a really good predictor. Or if class 6 is frogs, it's learned that a smear of green with a bright spot is a super strong clue. It's not seeing a frog, It's just picking up on the most common colors and shapes for each category. And this is absolutely the most important thing to get. The network never learns the concept of a car. It has no idea what a wheel is, or a windshield, or an engine. It only learns that a certain arrangement of colored pixels is highly correlated with the label car. That's all it is, pattern matching on a massive scale. So we just peeked inside a very simple AI mind, and it learned these fuzzy, abstract templates. It really makes you wonder, doesn't it? What do the gigantic AI models of today, the ones trained on basically the entire internet, what do they see when they close their eyes? What kind of unbelievably complex, intricate patterns do they dream of? That's really something to think about.